All right, let's talk about something in JavaScript that trips up, well, just about everyone at some point. Memory management. We're going to break down exactly how it works, so you can write better, less buggy code with a lot more confidence.
So, let's kick things off with a question that seems simple on the surface. When you type let my variable equals, where does that variable, go? The answer is surprisingly deep, and it really pulls back the curtain on how JavaScript organizes everything you create.
And the answer is, it goes to one of two very different places. You can think of them as two separate worlds living inside your program's memory, the stack and the heap. And each of these worlds has its own strict set of rules for storing your data. Getting these rules down is the key.
Okay, so before we take a tour of each of these worlds, let's just get a quick bird's-eye view, a high-level comparison to see what they're for. This is really the foundation for everything else we're going to talk about. Now, look closely at this. The top row is simple. Stack is for simple, primitive stuff. Strings, numbers. Heap is for the more complex things, objects, arrays. But that bottom row, that is the whole game. The stack gives you a fresh copy of your data. The heap, it gives you a reference, basically an address, pointing to the original data. This one little difference is the root cause of so many bugs.
All right, let's start with our first stop, the very orderly, very predictable world of the stack. This is home base for all of JavaScript's primitive data types.
Let's use this little piece of code as our guide. It's super simple. We're just creating a variable, making a second variable from the first one, and then changing the second one. Let's see exactly how the stack handles this.
Okay, let's walk through this. Line 1, my YouTube name is created, and its value, that string, is put directly onto the stack. Now line 2, and this is the important part. When we create another name, the stack makes a brand new, completely separate copy of that value. So when we change another name on line 3, the original my YouTube name is totally untouched. They are two separate things.
And this behavior has a name, of course. It's called pass-by copy. It's a fundamental rule of the stack. It's what makes primitive types so safe and predictable. They're always isolated from each other.
So the main thing to remember here is just this. With primitive types, your strings, numbers, booleans, you always get a fresh, safe, isolated copy. Any changes you make in one place won't create bizarre side effects somewhere else in your code.
Okay, that all seems pretty straightforward, right? But what happens when we're not dealing with simple strings? What about more complex data structures like objects or arrays? Well, that's when this whole system changes. In our other world, the heap has to get involved.
And that brings us to our second world, the heap. Now, the heap is a lot less organized than the stack. You can think of it as more of a chaotic open space, but it's also much more flexible, and it's designed specifically to handle those bigger, non-primitive types.
Okay, look at this example. It looks almost identical to the last one, doesn't it? We create a user1 object, we make a user2 from it, and then we change a property on user2. But because this is an object, the result is going to be completely different.
Pay really close attention here, because this is the whole trick. Step 1, the actual object data is stored in that big open heap. The user1 variable on the stack doesn't hold the object itself, it just holds a reference, like a little signpost pointing to the object's location in the heap. So, when we create user2, JavaScript doesn't copy the object, it just copies the signpost. Now both variables point to the exact same object. So when you change the email through user2, you're actually changing that one original object that user1 is also looking at.
And this, as you might guess, is called pass-by reference. It's absolutely fundamental to how objects, arrays, and even functions work in JavaScript. You're not actually moving the data around, you're just passing around little pointers to it.
So, let's just hammer this home. Unlike the stack, where you get a nice, safe copy, any change you make through one reference to an object in the heap is going to be seen by every other reference that points to that exact same object.
Okay, so you're probably thinking, this is kind of cool, but so what? Why is this distinction between a copy and a reference actually critical for me when I'm just trying to build an app? Let's break down why this really matters.
Let's just sum it all up. Your primitive values live on the stack. They're safe, they're passed by copy. Easy. Your objects live on the heap. They're shared and they're passed by a reference. Here's the danger and the reason this all matters so much. If you're not consciously aware that you're holding a reference, you can accidentally change data that's being used by a totally different part of your application, causing some really confusing bugs. Understanding this one distinction is your best weapon against those "how on earth did that value change" moments.
So,
I'll leave you with a question to think about. The next time you're debugging and you see a value change when you didn't expect it to, just stop and ask yourself, is this data living on the stack as a copy, or is this a reference to something shared on the heap? I promise, just asking that question will make you a much more effective debugger and a much stronger developer.